Okay, in this question, we assume that the SAT scores are normally distributed. This is very important, with mean 1518, so the mean is 1518, and standard deviation 325. So this means that sigma is 325. Okay, so let's keep these in with red, and normal distribution is important here. And now you have 25 SAT scores that are randomly selected. Find the probability that they have a mean between 1550 and 1575. So probability they have a mean. So look, find the probability that they have a mean between these two. So we want the probability that the sample mean, this here, for the sampling distribution is between 1550 and 1575. Before we solve, notice one thing. We have 25 SAT scores. So this is telling us that our n, in this case, the sample size n is 25. But notice this is less than 30. We said that 30 would be our number to be able to change to Z scores. That is true, but for any distribution. But when you have a normal distribution, the number is irrelevant. So even 25, even though it's less than 30, but because we have a normal distribution, you can use the number 25 as n. So now we change to the Z score. As you know, if you watch the previous parts, you know how to do this. Instead of x bar, you will put x bar minus mu over sigma divided by radical n, and you do the same for the two numbers here. So this will be 1550 minus, the mean is 1518, divided by sigma is 325, divided by the square root of 25, the sample size. And on the other hand, the other one is 1575 minus 1518, divided by standard deviation 325, divided by radical 25. Okay, and if you do this, you'll get the probability of, the one in the middle, of course, is the Z score, is between, the first one will be, if you approximate it to 2 digits, it will be 0.49, and the second number, if you approximate it to 2 digits, it will be 0.88. So let me just remind you that this number here is, if you do it on the calculator, you'll get this. And the number here, if you do it on your calculator, you should get this approximated to 2 digits, of course, after the decimal. For Z score, we always approximate to 2 digits. So now we know that the probability that a Z score falls between two numbers is the probability that Z is less than the bigger number, 0.88, minus the probability that Z is less than the smaller number, 0.49. And now we go to the Z table to find these values. So 0.88, it is 0.8 is here, and another 8 is there. So if you go with it, you'll get this number here, 0. So probability that Z is less than 0.88 is equal to 0.8106. This we get it from the table. So I'll put it back. This one was 0.8106 minus, let's do the second one. The second one is, we need to find 0.49. So 0.4 is here, and 0.09 is here. And so you move with this till the end, and so you'll get this number here. And I'll make it bigger, so I'll say probability that Z is less than 0.49 is equal to 0.6879. This is the number that we have here. So 0.6879. So I will subtract it from this 0.6879, and if you do this subtraction, you will get 0.1227, and this would be our final answer. And you can write it, of course, as a percentage, 12.27%. And this would answer the question, and I will stop here.